Hello everyone, welcome back. Today I'm going to be going over an example of how to use method of sections to solve a problem. So this is from one of your group quizzes, and it said, what is the load in member ij in pounds? Okay, so ij is right here, and we can solve this. So let's get to it. Now the first thing I need to do is draw a free body diagram. To do that, I'm going to replace my supports with their respective reaction forces. These are forces, they're not moments. I'm going to label them. So AX, AY, and GY. And because I'm a ninja and I know how this problem goes, I know exactly which one of these I want to solve. Maybe you don't. That's okay. So let's do it completely blind and solve for all three. First off, you have three equations when you're doing method of sections for a free body diagram that has size. If it's a point, you only have two. Some of the forces in the x direction, some of the forces in the y, and some of the moments about some point. Let's start with some forces in the x direction. So it's always going to equal 0, and there's only one force in the x direction, so that's ax, which means that that equals 0. That's an easy one. That's actually fairly common in most of your problems. Not all of them, but most of them. The next one I'm going to do is I'm going to go completely blind, so I'm just going to go down the list. There's some force in the y direction, so it's equal to 0. It's going to be equal to AY plus GY minus 8,000. Therefore, AY plus GY is equal to 8,000. If I look at this, sadly, I can't solve that yet. I don't know enough. That's supposed to be a G, not an 8. There we go. And so I'm still stuck. And the last thing you're going to do is take some moments about some point. My advice is to take a point where the forces, the line of action of the forces, for several of your forces go through it. In this case, it's pretty simple. It's either going to be A or G, and either one would work. I could also, if I wanted to, do point D. But if you can get rid of an unknown, get rid of an unknown. And wherever you take this in the moments, you're going to get rid of an unknown there. So I will do some moments around A. It's going to be equal to force times distance. So each of these right here is 8 feet. So 8, 8, 8. That works, yes. So it'll be 8,000 times 24 minus GY times 48. That's equal to 0. And if I solve that, what I get is that GY is equal to 4,000 pounds, and therefore AY is equal to 4,000 pounds. Beautiful. Okay, now I said we're going to use method of sections to solve this. So far, this hasn't been method of sections at all. It's just been regular. Now let's do method of sections. For the method of sections, I have to cut through my member. Now I want to make sure that I actually cut through what I care about. I care about ij, so I'm going to cut through ij. Also, I want to make sure I don't cut through more than 3 members at the same time. So 1, 2, 3, all is well. Whew. Thank goodness. Now I have to determine which side I'm going to keep. My advice is to get rid of as many forces as you can. And for reasons that I'm not going to quite explain right this second, I want to get rid of this side. So when I do that, it ceases to exist. It no longer is there, just scribbled out. It no longer happens. And I replace where it was with little forces here. Okay, now let's redraw my free body diagram. It should look something like this. Let's make sure I do it all correctly. There we go. And we have some forces. I'll call this force ij. This one right here, force cj. And this one right here, force cd. I also have my reaction force I saw for earlier, 4,000 pounds. Now, you might be wondering why I kept this side. It's because when I go to this one, I get 3 new equations. Some of the forces in the x, some of the forces in the y, and some of the moments. And I chose this side rather than the other one is because when I take the sum of the moments around point C, right here, neither this force or this force does anything. They don't cause a moment around point C, which means I can solve this with just one equation. I do have to figure out how high that is. Let's see, it's 12. So that means 4 here. That'll be 4 more here, and then 4 more at the top. So that'll be 8 feet right there. That's from geometry. Okay, so force times distance, and we'll say that this direction is positive. So 4,000 times 8 is 16, okay, minus force Ij times 8 is equal to 0. And I solve, and what I get is that force Ij should be equal to 8,000 pounds. If I've done everything correctly. Not always a given. Okay. But that is it. That is all you need to know. Now, if you're wondering, is it tension or is it compression? Draw your arrow away from the point. If it's positive, then that's tension. If it's negative, drawing your arrow away from the point, that's compression. So, with that, you solve this problem. So I hope this helped you, and I hope I actually got the right answer. Should check that beforehand. And if you got any questions, or if I made a mistake, please email me, and I will make some more examples for you. Have a wonderful day. Goodbye.